You ever wonder what's really going on behind the scenes when your favorite app just freezes up? Well, in this explainer, we're going to pull back the curtain on the powerful and often surprisingly fragile systems that run our digital lives.
I mean, we've all been there, right? Staring at that spinning wheel or some frustrating error message, just wondering why is it so hard to make software that just works? It turns out the answer is hiding in this invisible world of data, difficult choices, and some truly brilliant engineering.
So, our guide for this journey is this incredible book. And look, it's not just for hardcore engineers. It basically decodes the fundamental rules that run everything, from your social media feed all the way to your online bank account. And it all boils down to these three huge ideas: reliability, scalability, and maintainability. You can think of them as the foundation for our entire digital world. And right now, we're going to jump right into the first two. All right, first up, let's dive into the unseen digital world, where we'll get into the big ideas that keep everything humming along. Okay, so that brings us to our first huge pillar: reliability. And this is a really cool idea. It's not about trying to prevent things from breaking. It's about designing systems that expect to fail and just keep working anyway. So the crucial point here is that reliability isn't about making a system that never ever has problems, because that's literally impossible. Stuff always breaks. The real magic is building systems that can take a hit and just keep on ticking, giving you the right answer no matter what's going haywire behind the scenes. And what can go wrong? Well, pretty much everything. Your hardware can die, the software's going to have bugs. But what's wild is that studies of huge internet services found that the #1 cause of outages wasn't a hard drive failing. Nope, it was a human operator making a configuration mistake. That's right, human error. So, what's one of the weirdest, most confusing problems you can run into with these systems? It's something that kind of messes with our basic understanding of reality. A problem with time and who saw what when. And check this out. This is a perfect example of what I'm talking about. Mr. Poons asks a question, but because of a tiny delay, what engineers call replication lag, somebody watching this conversation sees Mrs. Cake's answer before they see the question. To an observer, Mrs. Cake looks like she can read minds. And that right there, that violation of cause comes before effect, is what engineers call a causality problem. When our systems do this, they don't just feel a little slow. They feel fundamentally broken and just weird. All right, let's move on to our second big pillar: scalability. Or, as I like to think of it, what happens when your app gets too popular too fast? This really is the great challenge of success, isn't it? The system that you built for 100 friends is just going to fall over and die when 1 million people show up. Scalability is all about designing for that growth from the get-go. So you've got two basic moves here. You can scale up, which is basically just buying a bigger, badder, super expensive computer. It's simple, but man, it gets pricey. The other option is to scale out. Instead of one giant machine, you just add lots of cheaper, normal computers to the team. It's more complex, for sure, but you can handle an almost limitless amount of traffic that way. But being scalable isn't just about handling more users, it's also about staying fast. And here's a quote that really nails one of the sneakiest problems out there, where it doesn't take a full system crash to slow things down. Sometimes just one slow process can jam up the works for everyone else. Yeah, they call this head-of-line blocking, and the coffee shop analogy is perfect. You know that feeling, right? You're in line, and the person in front has this super complicated 20-step coffee order, and the whole line just grinds to a halt. That's exactly what can happen inside a data system. One slow request makes the whole thing feel sluggish for everybody. Okay, so we've talked about being reliable and handling tons of users. But how do these systems actually find the one piece of data they need in all that mess? That brings us to the language of data itself. I mean, really think about it. How does a database find your one profile out of literally billions of others in less time than it takes to blink? It feels like magic. But it's just really, really clever engineering that we totally take for granted. Okay, so one of the main tricks is something called a hash index. Just think of it like a super smart table of contents that the computer keeps in its fastest memory. Instead of reading the whole book, which is on the slow disk, it just looks up your name in the index, and the index tells it exactly what page number to flip to. It's incredibly fast. Okay, but here's where things get really interesting. What happens when two different people, or two parts of the system, try to change the same piece of data at the exact same time?
This is where the sneakiest, most maddening software bugs are born. Check out how this can happen. Dr. Alice looks at the on-call schedule. She sees 2 doctors are working, so she thinks, great, I can take the night off. But at the exact same time, Dr. Bob does the same check, sees the same 2 doctors, and makes the same decision. The crazy part is, both doctors did the logical thing based on the info they had. But because they did it at the same time, the result is a total disaster. Nobody is on call.
So this scary situation has a name. It's called right skew. And it is an absolute nightmare for developers because it's so hard to even notice it's happening. For you and me, this is the kind of bug that causes your flight to get double booked, or that thing you just bought to suddenly be out of stock. It's a perfect example of that hidden complexity we've been talking about.
All right, so let's zoom out and look at the single biggest lesson from all of this. Let's talk about trade-offs and what comes next.
Yeah, it really all boils down to one word: trade-offs. See, when you're building these massive data systems, there is no such thing as a perfect solution. You can't have it all. Do you want it to be faster? Well, it might get less consistent. Do you want it to be cheaper? It might be less reliable. The real art is in choosing the right set of trade-offs for whatever it is you're trying to build.
And that brings us to this final thought from the book, and it's a really important one. It's just such a powerful reminder that all these technical decisions we've been talking about, they're not just about code and servers. They have a real human impact on the world we all live in.